You have understood the result of 36 operations, means 36 multiplication and their results in C3v multiplication table. But how exactly those results are obtained? For that, our imagination is important. What I am considering? I am considering bird view of the ammonia. Means imagine a pyramidal shape ammonia molecule, nitrogen and 3 hydrogens are there. That pyramidal ammonia molecule is kept in the open ground, and the bird is flying and going to observe that the ammonia molecule. Then how the bird will feel? Bird will feel as if like it's like a steering. Nitrogen is at the center and 3 hydrogens are there at the end. If I imagine a circle, then it will feel like a steering with 3 bars inside. So let me consider it is a 1 NH bond making 120-degree angle, other NH bond, and further 120-degree angle, a third NH bond. And vertical planes are there, those are passing through the NH bonds. A vertical plane passing through nitrogen and upper hydrogen, that's the first vertical plane, sigma. In anti-clockwise direction, from your point of view, of nitrogen and this hydrogen, this plane I am considering as sigma dash. Means what I did, this is sigma, while moving from sigma to sigma dash, anti-clockwise direction I preferred, and this is sigma double dash. So 3 planes, sigma, sigma dash and sigma double dash. And during rotation, 2 options are there, clockwise rotation and anti-clockwise rotation. I am following positive rotation. Which is positive rotation? Clockwise? No, anti-clockwise rotation is positive. So I'll rotate the molecule by anti-clockwise direction. Means if I rotate molecule by 120 degree, then this hydrogen will come to the position of this hydrogen after rotation of 120 degree. And in order to distinguish all operations, I need to consider one knot. With the help of that, all operations we can distinguish. Means if I take reflection through this vertical plane, then this knot will come to this position. If I rotate, then this knot will come. This is a plane, other plane, that's a sigma dash, knot will come to this position. If I perform reflection through it, here is a knot. Reflection through this plane, that's a sigma dash, then this knot will come to this position. Here the other vertical plane is there, no, there's a sigma double dash, the below that knot will come. So you will understand clearly, pictorial presentations are given. With the help of that, let us understand multiplication table for C3v point group with an example of ammonia. It's our bird view of ammonia molecule. Nitrogen is at center and at ends of those 3 bars, hydrogens are there. From middle nitrogen to upper hydrogen, a plane passing through that NH bond, the plane is sigma. If we move in anti-clockwise direction, then middle nitrogen to left side hydrogen, the plane passing through that bond is sigma dash. If we move again in anti-clockwise direction, then middle nitrogen to right side hydrogen, a plane passing through that NH bond is sigma double dash. Means while labeling the planes, I am moving in anti-clockwise direction. Ammonia molecule has C3 axis. That C3 axis is perpendicular to our representation and it's passing through the central atom, that's a nitrogen. And whichever operations I need to perform by C3 axis, means C31 and C32, those will be in anti-clockwise direction. In order to distinguish all operations, here labeling nitrogen, H1, H2, H3 is not needed. Only one knot. Where is it? See now. It is to left side of the upper nitrogen-hydrogen bond. With the help of that black knot, we can distinguish all operations. Maybe it is a rotation operation or reflection operation. If I rotate this molecule by say 120 degree, the anti-clockwise direction, then that knot will come to lower side of left bar, left NH bond. Similarly, if I continue the rotation by further 120 degree, means total by 240 degree, then that knot will come to the upper side of sigma double dash. That's our imagination. Properly you should able to work with it. If I perform the reflection operation through sigma, then the knot now is to left side will come to right side. If I perform the reflection through sigma dash, then that knot will come below the right side bar. Means that's a sigma double. You are finding that bar. That's a NH bond. Below that bond, if I reflect through sigma double dash, then that knot will come near to left side bar, but where? Upside or downside? Right upside. Yes. With this, you will understand how can we perform the various operations. Let us start to develop or construct our multiplication table with this ammonia molecule. Total 36 results of multiplications are there in the multiplication table. Those 36 results I can divide in the 4 parts. Each part of 9 results will be the quadrant. Left side quadrant has the multiplication of axis and axis. It is very easy to understand, but can be derived by our method. Actual importance of this pictorial presentation is to explain the multiplication between the axis and plane, plane and axis, plane and plane. So there I want to focus. Let me start our multiplication table generation of the second quadrant from the second row, and the element there in the second row of the left side column of the all operations is C3-1. C3-1 means rotation by 120 degree. After rotation of 120 degree, I want answer from you. The knot whichever is to left side of the upper bar, upper NH bond, where will it come? It will come to the left bar. Yes, I agree, but where? Upside or downside? It is to the downside of the left side bar after 120 degree rotation. Now I want to perform next reflection operation through a plane sigma. Molecule is rotated, but our planes will not rotate. Plane will remain as it is. What is our consideration about the sigma plane? Sigma plane is passing through central nitrogen and upper hydrogen, whatever may be the kind of rotation. I want to reflect the result obtained through a plane sigma. What do you think? After reflection, that knot will come to, of course, right side, but I want answer from you. It will come to bottom portion of the right side bar or upper portion of right side bar? Bottom portion of right side bar. So this is a result of sigma reflection, or I can say extreme right side structure is a result of C3-1 as well as sigma, or C3-1 into sigma. Now I have to ask a question. Whatever the resultant structure is there represented at right side, how can I get that resultant structure from original structure? Think on that. How can I obtain resultant right side structure from original structure? What's your answer? Right, that we can achieve by sigma dash operation on the original structure. What is the meaning of this representation? C3-1 into sigma is equal to sigma dash. What our multiplication table says. Let us see. Here also C3-1 into sigma is equal to sigma dash. Now let us generate the next position, next result, C3-1 into sigma dash. Let us prove. It's our ammonia molecule and 3 NH bonds we are representing by 3 bars, and for distinguishing purpose I am considering one black knot and it is to the left side of the upper bar. Pay attention towards sequence of labeling of planes sigma, sigma dash and sigma double dash in anti-clockwise direction. If I perform C3-1 operation means rotation by 120 degree, that's a black knot will come towards the left bar. Where? Upside or downside? Right, downside. We are right. Let us reflect this molecule through a plane sigma dash. Sigma dash is a left side plane. After reflection, that knot will go upside of the left bar or will remain there only? Right. It will go upside. Now important question we have to ask. How can I get resultant structure from the original structure? Yes, think on this. See all possibilities and I want answer. That answer will be the multiplication between C3-1 and sigma dash. And answer is sigma double dash. Let us see what our multiplication says. The multiplication of C3-1 and sigma dash is Right, sigma double dash. Now I want to construct the next point, C31 into sigma double dash. It's our interesting ammonia molecule with sigma, sigma dash, sigma double dash as the three planes in anti-clockwise direction, and one knot for distinguishing is to the left side of the upper NH bond. After C31 operation, knot will shift to the bottom of the left side bar. After sigma double dash operation on the resultant structure, knot will shift to the right side of the upper bar. How can I get this final structure from the original structure? Yes, you are right, through reflection. And our answer is sigma. What does it mean? C31 into sigma double dash is equal to sigma. Let us see what our multiplication table says. We are right, C31 into sigma double dash is equal to sigma. Let us prove the other result. It's our beautiful ammonia molecule with three planes sigma, sigma dash and sigma double dash in anti-clockwise direction, and the knot is to the left side of the upper bar. Let me perform C32 operation on this molecule. C32 means rotation by 240 degree. What do you think? After rotation that knot will come? Of course to the right side, but it will be to the lower portion of right side bar or to upper portion of right side bar? Yes, it will be to the upper portion of right side bar. After sigma operation on the resultant structure, the knot will come to left side, of course, but where will it? Will it come to the upper portion of left side bar or to the bottom portion of left side bar? Yes, it will be to upside. How can we get this resultant structure from the original structure? Which operation shall I perform on the original structure so that the final right side structure I can obtain? Absolutely, by sigma double dash operation. What does it mean? C32 into sigma is equal to sigma double dash. Let us see what our multiplication table says. Yes, C32 into sigma is equal to sigma double dash. We are right. Let us construct next point. Beautiful ammonia molecule with three bars, and the left side upper bar there is a knot. And sigma, sigma dash, sigma double dash are in anti-clockwise direction. After C32 operation means rotation by 240 degree in anti-clockwise direction, that knot will come to the right side, but where? To the lower portion or upper portion of the right side bar? Yes, to the upside. Now on this resultant structure, I want to pop reflection operation through sigma dash. What do you think? Now by reflection through sigma dash, that knot will come to upper side certainly, but to left side of upper bar or right side? Right, to the right side. Now I have to ask a question. How can I produce this resultant structure from the original structure? And answer is reflection through sigma. What does it mean? C32 into sigma dash is equal to sigma. And our multiplication table also says C32 into sigma dash is equal to sigma. Therefore we are right. Let us construct the next point. Ammonia molecule with three bars, labeling of the plane sigma, sigma dash, sigma double dash in anticlockwise direction, and knot is to the left side of the upper bar. After C32 operation, that knot will come to upside of right side bar. After sigma double dash operation, that knot will come to, yes, it is below the right side bar. How can I result right side structure from the original structure? By simple sigma dash operation. Yes, and our multiplication table also says C32 into sigma double dash is equal to sigma dash. I discussed here the last few results fastly because I want that you have to work. You can pause the video again and you can go through that, or you have to work on paper. You work, that will help you for the examination. Out of the four quadrants, right side quadrant discussion we did. In that right side quadrant, upper row, that's a sigma, sigma dash and sigma double dash. That's a multiplication identity. That we have not shown here. But other two rows, those six results I described in this video. We need to discuss the other quadrants also. But is the discussion of multiplication between axes and the plane clear to you? Try to find the sequence there in that representation. As a homework, I ask you the multiplication that we are going to perform in the next video. That's a multiplication between the plane and the axis. I want the answer from you. Result of multiplication of sigma dash and C31. I'm waiting for your answer in the comment box.